In this problem, we have a skier. His mass is 60 kilogram. He's sliding down the slope. Therefore, we can neglect friction. At point C is located at x equals to 12 meter. So this is 12 meter. He has a speed of 8 meter per second. We need to determine the normal force exerted on him by the slope at point C, as well as its total acceleration. So we can do a quick analysis to determine how we are going to solve this problem, what our strategy would be. At point C, if we do a quick free body diagram, he's subjected to his weight as well as a normal force. Because we do not consider friction, that's those two are the only forces he is subjected to. And then that's the free body diagram. And then if we draw a quick kinetic diagram along the tangent to this direction, tangent to his path, this is the tangential acceleration component. And then normal to the path, this will be the normal acceleration. So as you can see, if we can determine an, then we can summarize the total force along the n direction, and from there we can solve for the normal force. And an, we know that is determined by v squared over rho. So the speed is given, that's 8 meter per second. Therefore, we need to use the y-x equation, this relation right here, as well as this equation to determine rho. So that's our strategy. So let's now start to solve this problem. Because y equals to 0.025 x squared plus 5, therefore dy dx equals to, take the derivative, 0.05x, and then the second derivative will equal to 0.05. Therefore, at x equals to 12, this is at point C, dy dx equals to 0.05 times 12, and that is 0.6. Therefore, and the second derivative is always the same. Therefore, rho, the radius of curvature at this point, equals to 1 plus 0.6 squared raised to the 3/2 power, and then this will be simply 0.05, that is already positive, and this equals to 31.7 meter. That's the radius of curvature here. Therefore, an equals to v squared over rho, which is 8 squared over 31.7, and that is 2.018 in the unit of meter per second squared. So we have determined an. So the next thing to do is to draw a free body diagram of the skier. Weight force, which equals to mg, which is 60 times 9.81, and normal force, n. And we already said that if we draw the kinetic diagram along this direction, that's our an. And then along this direction, which is perpendicular to an, that's our at. So now we're almost ready to write our equations of motion, except that we don't know the direction of the normal force yet. So for that, if we look at point C, we realize that this line right here is the tangent line of the curve. If we know the direction of this tangent line, we would know the direction of the normal force, because this is a 90-degree angle. And this tangent line right here, this angle theta can be determined by, in this case, the change in y. So delta y over delta x, which is simply the slope at this point, and that simply equals to dy dx. Therefore, from there, we can solve for theta equals to arctangent, because tangent theta equals to dy dx, which is 0.6. So theta equals to arctangent 0.6, and that equals to 30.96 degree. So now we're ready. Resultant force along the normal direction, which is in this direction, equals to, normal force is along the normal direction, and our weight force can be resolved into these two components. This component right here equals to negative weight force times cosine theta, which is n minus 60 times 9.81 times cosine 30.96 degree. On the right hand side, it equals to MAN, which equals to 60 times, we just determined AN, 2.018. So from this equation, the only unknown is normal force. We can solve for normal force. So from here to here, only unknown is normal force N. So we can solve for normal force, and that is 626 Newton. So that answers the first part of this problem. We can also write the resultant force along the tangent direction. Normal force does not have component along the tangent direction, only the weight force, this component right here, which is W sine theta, which equals to 60 times 9.81 times sine 30.96 degree, and that equals to MAT, which is 60 times AT. So as you can see, the mass 60 can be cancelled out from both equations, both sides of the equation. Therefore, AT simply equals to 9.81 times sine 30.96 degree. So from there, AT can be solved to be 5.05 meter per second squared. And since we have both the AN 2.018 and AT, from there we can determine the total acceleration, which equals to the square root of AN squared plus AT squared. Plug in those two numbers, and that is 5.44 meter per second squared. So that's the answer to the second part of this problem.